You're good to go. Hello.
Hi, everybody. Welcome to Dome to Home. We're going to wait just a minute so people can get logged on, refresh their browsers, all that good stuff. How's everybody doing?
Feel free to say hi down in the chat.
All right. Everybody should probably be getting in right about now. Give me a second. All right, let's go ahead and get rolling. So hi again, welcome to Dome to Home. My name is Tara. I am a presenter here at Fiske. I also have Ms. Amanda here with me. She is our navigator for the day. Say hi, Amanda.
Oh yeah, I'm excited to fly around and show you guys some cool summery stuff.
Yeah, so Amanda is our navigator. That means that all of the stuff that you see on the dome here on my right, all of that is being done live by Amanda while we're doing it. So she's working real hard over there. We also have our friend Rainey here. She's monitoring the chat window. So if you guys have any questions during the talk or anything you want to know about, go ahead and drop us a line in that chat window and she'll relay that. We'll try to get to as many of them as we can. I'll try to answer some as we go, but then we'll have a couple minutes dedicated at the end too, where we can just talk about questions. So today we are here celebrating the summer solstice, which is actually on Saturday. Saturday the 20th is the solstice. So I figured we'd start off by talking a little bit about what that actually means. What is a solstice? So you can see here on our dome, we are at the lovely Farron Field here at the University of Colorado. Now, probably the most obvious thing that we notice here on Earth for a solstice in the summer, our summer solstice is the longest day of the year. Now, that means that the sun is at its highest point in our sky on that day. Now, maybe it's not something that we recognize right away, that our sun is actually at different heights during different times of the year. Here in the mid-latitudes, it's not quite as obvious, but think about people that live at the North Pole or the South Pole. You've probably heard of them having 6 months of light and 6 months of darkness, or a couple months where the sun never rises. That's why. It's the same thing. And we're going to look at it from space here in a second, but I want to give you an idea of kind of what it looks like from down on the ground. So we're still on Farron Field, but we have laid down now so we can see our whole sky up above us. And you can see these lines that Amanda has put up there. Now, if you're having trouble seeing the lines on the dome, if it's very, very small, try maximizing your screen, full screen, your video there. So then you should be able to see those a little bit better. So you can see now that our sun is kind of along that red line up at the top. That's our summer solstice line. So at the summer solstice, the sun is traveling on that really high line up in the sky. But you can also see that we put the labels up, the line in the middle for the equinoxes, and then the line for the winter solstice at the bottom. So just like the summer solstice is the highest point in the sun rises in our sky, the winter solstice is the lowest point that the sun will go across our sky. And then the equinoxes, spring and fall, halfway between summer and winter, it's right in the middle. So let's kind of fast forward through time so you can see how the sun moves over the course of a year. Amanda's going to let us time travel.
Absolutely.
So our sun is setting and you can see it following that path there.
And you'll notice one thing that's pretty cool is during the equinox, the sun rises exactly in the east and sets exactly in the west, which is pretty neat.
Oh yeah, you can see that really well. There's our beautiful night sky. Not quite what it looks like from here in Boulder. We've removed a lot of the light pollution there. But as time goes on, we'll see our sun come back.
Coming around, we're at about 3 a.m. now. If you can stay up all night, you'd be able to see the stars move just like that.
There you can see the moon kind of rising there in the center too. The moon's not always really close to the sun, but right now it happens to be. So if you ever go out and see the sun rise, you can see the moon pretty close to it. And see, there's our sun again, moving right along that solstice line. And so that's what we see from down here on Earth. And that's what a lot of ancient peoples always looked at when they were noticing the way that the sun moves in the sky. But we can also look at it, because we're in a planetarium, from out in space. And this gives you a much better idea of why our sun appears to move in our sky like this. The sun itself is not actually changing position. Because the sun's at the center of the solar system, it's just chilling right there in the middle. The reason that it appears to move in our sky all boils down to one fact. It's that the Earth is tilted. So as the Earth is going around the sun on our path every year, it's not straight up and down, it's actually tilted just a little bit, 12.5 degrees to be exact. And we're going to give you a good look at kind of what that looks like here. So you can see our sun there in the middle. That blue line is the orbit of the Earth. We're going to show you kind of edge on so you can see. You can maybe see there's a little white line running through the Earth that shows you where the tilt is.
We'll try to get our Earth right around here so that you guys can see that line.
Yeah, it's coming up now.
There you go, yeah.
So you can see the tilt of the Earth there. You can also see the line where the equator is. So that's right around the center of the Earth at the fattest part, and you can see that it's not straight across. It's kind of wobbled. Now, when we look at the Earth like this, you can see that the sun is shining light on the Earth, but because the Earth is tilted, like in this vision you see right here, the southern hemisphere is getting more light, more direct sunlight than the northern hemisphere. And because we're tilted like that, that's the point where that sun's going to look lower in our sky. So that is our winter solstice. That's where we're receiving the least amount of direct sunlight here in the northern hemisphere. And of course, it's the opposite in the southern hemisphere because they're getting the most light. So winter solstice for them means that the sun is highest in their sky. Now, as the year goes on, the Earth continues to go around the sun, but that tilt remains the same. So as we're moving around, we'll go 3 months or so. So we're moving out of winter and towards spring here.
And we'll have to do a little flipperoo. It looks like I'm upside down. So we're looking down on our solar system. The Earth actually goes counterclockwise. So I'm upside down right now, but we'll fix that and then you'll be able to see it a little better.
Space is hard. That's the fun thing. There's no up or down in space. It's all sort of relative. It makes Amanda's job tricky.
There we go.
All right. So same view, different side. So now as we watch the Earth go around, so now you can see it's still our winter, but we're moving around here. Now we get to all the way over to 6 months later. And so now we're at the opposite season. Now, because we were upside down before, we had it the other way around. The northern hemisphere was getting the most sunlight, the southern hemisphere was getting the least. And so now as we move around, you can see when we get to that winter solstice, we're getting the least amount of direct sunlight. The southern hemisphere is getting more. And the points exactly in between for spring and for fall, they're right in between. That's where we're getting about equal amounts of direct sunlight in both the northern and southern hemisphere. That's why those are called the spring and fall equinoxes. Equinox just means equal light. And as it comes back around, you'll see we're starting to get more direct sunlight again. So that's the reason that we see this movement of the sun in our sky. It's not the sun that's actually changing position, it's the Earth as we move around the sun. And that's the same reason that we have seasons to begin with, because of this tilt and because of the way that the Earth goes around the sun. Now, obviously, we haven't been able to observe this particular phenomenon like this from out in space for very long, just about 50 years that we've been off of our planet. But we've known about solstices and equinoxes for much, much longer than that, way thousands and thousands of years ago. There were people who understood how these solstices worked. And they could use this to tell the different times of the year. They would use the sun and its position to know when to plant their crops, when to harvest their crops, when winter was coming, when winter was ending. And they had a lot of really cool ways to do this. One of the things that they used, probably the most famous one, is Stonehenge. You can see in Amanda's background there, she's got an awesome picture of Stonehenge. And we've got a really cool full sky view that you can see here on our dome. You've probably heard of Stonehenge. We're not really sure how it was constructed. We know it was constructed about 3,000 years ago. So there's still a lot of mystery surrounding it. But one thing that we do know is that for both the summer and winter solstice, you can use these stones to measure the timing. So on the summer solstice, the sun will set right in between two of those rocks, and it shines straight across the field to another stone that's farther out. They call it the heel stone. And so when the light lines up just right to move through that little crack into the heel stone on the other side, that's when they know it's the summer solstice. It's pretty cool. Now, another really cool one that's also in the UK, this one's in Scotland. They're called the 𝐀𝐜𝐭𝐢𝐯𝐢𝐭𝐢𝐬. It's just outside of Inverness in the north of Scotland, where it's really far up and they don't get a lot of sunlight in the winter, which is also pretty cool. But when you look down on it from above like that, you see how there's the center where it's open and then the kind of path that goes down the middle. So these are used as burial mounds. That's why they're kind of hollow in the middle. But on the summer solstice, the light from the sun would shine right down the center of that line and into the chamber in the middle. Now, why they did that, we don't really know, but it does show that they had a remarkable understanding of how the sun moved around. And this was about 2,000 years ago, so also very, very old. You can see that's me standing in the middle. Now, there's another really cool one. Yeah, it was really, really neat. There's like 6 or 7 of these that are scattered all around this little area. So they're really cool burial mounds. There's lots of neat stuff over there. But yeah, a little bit closer to home, the Native Americans here in the Colorado and New Mexico, Arizona, Wyoming area had something called the medicine wheels. Now, there were a lot of these that we found pieces of, but this particular one that we're showing you here is in Wyoming. It's close to the border with Montana, and it's the best preserved example of a medicine wheel. They're even found all the way up into Canada, so these are all over the place. Now, what you're seeing here is there's 28 spokes on this wheel. There's one for each day of the lunar cycle. So a lunar cycle from new moon all the way back to the new moon takes 28 days, or a month almost. But by watching the location of the sun and seeing how it moves across those spokes over time, they could predict when the solstices were going to occur with really, really precise accuracy. And again, this was thousands of years ago they were using these. The picture on the bottom there kind of gives you an idea of how that works. You could see where the sun was in relation to the spokes. They also used some stars like Rigel. They would see where Rigel was in relation to the spokes, and that would tell them some things about the time of year and when things were coming. Oh, we got way zoomed in there.
Yeah, zoomed in a little too far there. But hopefully you guys can read that.
Yeah, so there's some really, really cool ways that we've been able to measure the solstice even long before we knew exactly why it was happening. Before we knew that this is how space works and how the Earth works. Even down here from Earth, we could still kind of figure these things out thousands of years ago. And I think that's really cool. Now, that's a little bit about the solstice itself and kind of how we measure it and how we look at it. But I also wanted to take a couple of minutes that we've got left to show you guys some cool things that are happening in the sky this summer. Now, it looks like here we have a question too. Did the latitude 45 degrees get represented by the standing stone, medicine wheels, etc., to measure solstices and equinoxes because of their midway? Let me see here.
And we'll re-show some of those 𝐀𝐜𝐭𝐢𝐯𝐢𝐭𝐢𝐸 while Tara's deciphering that. You can kind of see some of the alignments of these again.
Oh, okay. I think I see what Mr. McFarland is asking. Latitude 45. Okay, so do the stones represent the latitude 45 degrees because it's the midway point between the pole and the equator? Not exactly. They're not all at 45 degrees. The ones in Scotland are a lot higher up. They're around 60 degrees. I'm not sure about the one in Wyoming. That might be pretty close to 45 because here in Boulder, we're at 40 degrees. I'm not sure about Stonehenge either. I feel like it might be a little higher up, but I'm not positive. But that could be a really useful way to also decipher kind of the timing of the seasons and the movement of the sun. If you were at that 45-degree latitude, halfway between 0 at the equator and 90 at the pole, that would be a very convenient place to be if you're trying to measure the altitude of the sun in the sky and the timing of the seasons. So I don't know if there's any that are right on that 45-degree line. There probably are, but I don't know off the top of my head. It looks like I got a little bit of information. Stonehenge is at 51 degrees north. So it's a little farther north than 45. Excellent. All right, so let's take a look at some stuff in our sky because there's a lot of really cool things that come up in the summer. Right now, you've got a chance to see planets. After midnight, you got to wait a little bit later. But if you go late into the evening, you can see Jupiter and Saturn and Mars. Maybe not all at the same time, but just after midnight, you can see Jupiter and Saturn coming up. There they are. Amanda's just put them up there. And then later in the night, you can see Mars. It's actually into the early morning. So you got to either stay up really late or wake up really early. So you can see our counter there. We're moving on till about 1 in the morning. There's Mars. You see him coming up there.
And if you have a really nice telescope, you can get some great views of these planets. And being up that late is great for getting as darkest sky as you can too. So if you like planet watching, right around 2 a.m. is a great time to go out if you can stay up that late.
You can manage it. You can see Venus kind of over there too. Venus has been up a lot in the early evening recently, but it's starting to come around to where it's only visible in the mornings now. So lots of really cool planets that you can see there. Now you'll notice as we're kind of moving through the evening, those planets are rising in the east and sort of setting in the west, just like our sun does. You may also notice that the stars behind it are rising in the east and setting in the west. And this is just a consequence of the Earth turning again. It's not space that's actually moving that way, it's us that's moving. Now that means that constellations will do the same thing. And because just like we saw earlier, the Earth is moving around the sun, we're in different places in space at different times of the year. So we get to see different constellations at different times of the year. So we have winter constellations, we have summer constellations. The summer ones are some of my favorite. And so I wanted to point those out to you guys too. Now, the first one that we always look for is not an actual constellation. It's what we call an asterism, which just means it's a group of stars that aren't an official constellation. This one's actually made up of 3 different constellations. We call it the summer triangle because it's got those 3 constellations there, 1 star from each one. So we have the star Vega, which is in the constellation of Lyra. She can show you there. Yep, Amanda's circled Vega.
Yeah, there we go. And we get a nice bright Lyra in there.
So Lyra is a harp or a lyre, obviously, right?
Obviously.
Now we also have the star called Altair in the constellation of Aquila, the eagle. There's Altair down at the bottom, and it's kind of an eagle. You can see it's got like a head and wings.
Unfortunately, the art doesn't do that one much justice.
Not so much. But the third one is my personal favorite constellation, and it's the star is called Deneb, and it's in the constellation of Cygnus, the swan. One of the reasons I like Cygnus is because it actually looks like the thing that they say that it's supposed to look like. You can totally see a swan there with like big wings outstretched and a really long neck. I think that's really cool.
Absolutely. And just a little fun fact, do you want to tell them what Deneb means?
Yes.
Very appropriate.
It is. So the word Deneb comes from the Arabic that means rear of the swan. So that star's name is literally swan butt. Yeah, when I do it in the theater, everybody always laughs. So I'm going to pretend that you guys always laughed at that joke. So those are some of our favorite summer constellations. There's also some other cool zodiac constellations that you can see, like Virgo and Leo. Those are all going to be up in the summer. I would love to talk a little bit more about those and show you some more cool stuff, but we are out of time. And I wanted to give y'all a couple extra minutes in case you did have any more questions come through. Anything that you thought of that you were wondering about. Look at all those constellations. Constellations are really fun because they don't have to be what they tell you they are. Constellations are just made up by people anyways, so if you want to make up your own, you're absolutely welcome to. If you don't think that looks like a swan, you think it looks like something else, that's fine too. What else can we see?
Absolutely.
There's one up there that purple one that kind of looks like a house with legs. I like that one. Constellation of
I like that. Yes.
I think.
And we will do, I'm pretty bad about that. If you guys watch my videos, we're going to make sure our slow mode isn't on. All right. Yeah, you guys should be able to comment as fast and as many times as you want now.
Questions? If not, we can just keep looking at summer constellations.
Rainbow constellations are always a good time.
I like it. Another popular one, if you can still see Cygnus there, it's kind of white. If you see the white one that's just to the left of that, that's Pegasus, our winged horse. You can see it's kind of like his back legs a little bit. And the kind of V-shaped one next to that is a beautiful princess, Cassiopeia. Isn't she lovely with her sticks? Let's see, not a lot of questions today. That's all right.
Yes, everybody's excited to go out and see the solstice for themselves.
Yeah, like I said, that's on Saturday. So not quite yet today. It almost looks like the solstice right now. It's almost to the highest point in our sky. But Saturday will be the longest day of the whole year. And they put it on a weekend so we can go out and enjoy it. Here's a question from Denise. What happens with shadows during the solstice? Excellent question. So because the sun is the highest point in our sky, our shadows are going to look a lot shorter because it's farther up in the sky. So it's kind of shining more directly down on us. So rather than the sun at the winter solstice and it's low in the sky, it's shining this, kind of towards us. And so your shadows are going to look longer. But at the summer, it's right up at the top. And so your shadows look shorter. That's an excellent way to kind of wrap up, because I did want to remind you guys about the social media challenge that we had for this week, was to post a picture of a cool shadow, either yours or maybe a friend's or your cat's, or a cool tree, or a really neat shadow that you see around or on the solstice. Take a picture of it, post it online with the hashtag Dome to Home. We're checking out all of those. Now, also be sure to check us out next week. We're going to be doing another Dome to Home, same time, Tuesdays at 2 o'clock. We'll be talking about the craziest exoplanets, planets around other stars. It's going to be a whole lot of fun. We'll have a different social media challenge for that week too, so be sure to check out our website. And as always, like and subscribe to our videos here on YouTube. If you have any other questions that you think of, go ahead and drop them in the comments and we'll try to get back to you. Otherwise, we will wrap up for today. So thank you guys so much for joining us today. Thank you to Miss Amanda for navigating for us. And
thanks for joining us.
Yeah, hope to see you again next week.